Welcome to qnawire.
Okay, firstly, I've got to redraw the MDMA. Draw both versions of it. All right. And the first question is about this bond here. And the question is, what orbitals make up this bond? Well, we've got an sp2 hybridized carbon there and an sp3 hybridized carbon there. And that is, in fact, the answer. It's sp2 plus sp3, right? Remember, this is a carbon with 4 bonds. That's sp3. This is a carbon with 3 bonds. That's sp2. sp3 plus sp2, that's what that bond is made out of. Okay, next question is B. What is the electron geometry of the nitrogen atom? Okay, well, remember, this is a nitrogen with 3 bonds, which means it also has a lone pair. So this nitrogen has 4 electron regions. 4 electron regions implies that the electron geometry, Eg, is tetrahedral. The molecular geometry is trigonopyramidal, but the electron geometry is tetrahedral. Okay, C. How many lone pairs of electrons does this oxygen have? This is an oxygen with 2 bonds, which means it has 2 lone pairs. 2. Yeah. What is the name of the nitrogen-containing functional group? Okay, nitrogens with bonds only to carbon or hydrogen are referred to as amines. Or, singularly, it's an amine. Okay. On the structure above, label the chiral centers in each molecule as R or S. So let's take a look at this chiral center right here. Okay. And first thing we've got to do when we are determining whether a chiral center is R or S is assign priority to the substituents. I like to draw any hydrogens that aren't shown. We've got a hydrogen in the back here, and this nitrogen is the highest priority, followed by this carbon, which is attached to other carbons, followed by this carbon, which is attached only to hydrogens, and in 4th place is the hydrogen in the back. And when our lowest priority substituent is in the back, as we have it now, we can simply connect the highest to the second highest to the third highest priority with a circle and determine whether that connection is clockwise or counterclockwise. In the case that it is counterclockwise, as it is here, then the stereocenter is S. And that works when hydrogen is in the back, or when the lowest priority substituent is the back. When the lowest priority substituent is the back, counterclockwise corresponds to S, and clockwise corresponds to R. Now, let's look at a case where, hey, now our highest priority substituent is not in the back, right? So we'll start the process the same. We'll say nitrogen is the highest priority, second is the carbon attached to other carbons, third is the carbon attached only to other hydrogens, and 4th is this hydrogen. We'll connect highest to second highest to lowest, or third highest, rather, clockwise with the circle and see that it's counterclockwise. But since hydrogen is in the back, counterclockwise corresponds to R, whereas clockwise corresponds to S. So in this case, this stereocenter is R. So the one on the left is S and the one on the right is R. And the stereochemical relationship between those two stereoisomers, because the only difference is the complete opposite stereochemistry at one, or in this case, all stereocenters, is that these are enantiomers. Right? Enantiomers are basically mirror images or molecules in which you take every stereocenter present and invert it. There's only one stereocenter here, but it is inverted upon moving from the left molecule to the right, so these are enantiomers.